Hello friends, welcome to all of you. After discussing on the finite differences and various operator, today we are going to discuss on the chapter of engineering mathematics third, that is interpolation. In this chapter we are going to discuss or learn on the points, that is interpolation, extrapolation, what is mean by interpolation, what is mean by extrapolation, some formulas related to interpolation. So let's start. The definition of interpolation is that interpolation is the process of estimating the value of a function at an intermediate point, or the process of finding the value of the function inside the given range is called interpolation. Interpolation is the process of finding the most appropriate estimate for missing data. It is the art of reading between the lines of a table for making the most probable estimate. It requires the following assumption: the frequency distribution is normal and marked by sudden ups and downs. The changes in the series are uniform within a period. Interpolation technique is used in various disciplines like statistics, economics, business, population studies, price determination, etc. It is used to fill in the gaps in the statistical data for the sake of continuity of information. For example, if we know the records for the past 5 years, expect the third year which is not available due to unforeseen conditions. The interpolation technique helps to estimate the record for that year to under the assumption that the changes in the records over these 5 years have been uniform. And the extrapolation is the process of finding the values outside the given interval. Now interpolation with equal intervals. Let y is equal to f of x be an explicitly unknown function with given discrete set of points xi, yi, where I runs from 0 to n, where xi's are equispaced. Means there is a equal interval in between the values of x. The process of obtaining the value f of xi plus ph, where p lies between -1 to 1, where height of the interval h is fixed, is known as interpolation within equal interval. There are several methods of interpolating data points within a given range, depending upon the location where the value is to be interpolated, as given below. Newton's forward interpolation formula, Newton's backward interpolation formula, Gauss forward and backward interpolation formula, Stirling central difference formula, and Bessel's interpolation formula. Out of that, in this session we are going to discuss on Newton's forward and backward interpolation formula for equal interval. We shall discuss the methodology one by one in coming session. Newton's forward interpolation formula. This formula is used to interpolate the values of the function y is equal to f of x near the beginning and extrapolate the value when x less than x0 within the range of given data points xi, yi, where I runs from 1 to n. Let f of x takes the value y0, y1, y2 up to yn for the independent variable x, taking values x0, x1, x2 up to xn, where height of the interval h is fixed in between the values of x, such that x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, and xn is equal to x0 plus nh, like this. Then to evaluate f of x for x is equal to x0 plus ph, where p lies between -1 to 1, we have f of x is equal to f of x0 plus ph. In the form of shifting operator, we can write this function as e raised to p of x 0, which is equal to 1 plus delta. Instead of shifting operator e, we can easily write 1 plus delta raised to p y0. Here we see the reason. Delta shifting operator e is equal to 1 plus delta and f of x0 is denoted by y0. Then by expansion of 1 plus delta raised to p, we get f of x0 is equal to 1 plus p delta plus p minus 1 upon 2 factorial delta square plus p minus 1 p minus 2 upon 3 factorial delta cube plus and so on into y0, where x is equal to x0 plus ph. Therefore our formula become f of x is equal to y0 plus p delta y0 plus p minus 1 upon 2 factorial delta square y0 plus p minus 1 p minus 2 upon 3 factorial delta cube of y0 plus and so on, where p is equal to x minus x0 upon h. This is a Newton forward interpolation formula and is used to interpolate or extrapolate values near the beginning of the table. Now Newton's backward interpolation formula is used to interpolate the values of y is equal to f of x near the end, that is x is less than xn, and extrapolate the values when x is greater than xn within the range of given data points xi, yi. Let f of x takes the value y0, y1 up to yn for the intermediate variable x, taking values as x0, x1, x2 up to xn, where height of the interval h is fixed such that x1 is equal to x0 plus 2h, x2 is equal to x0 plus 2h, x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, and xn is equal to x0 plus nh. Then to evaluate f of x for x is equal to xn plus ph, means near the end of the given data points, that means the value of p lies between -1 to 1, we have f of x is equal to f of xn plus ph. Then we redefine this function in the form of shifting operator e, that is e raised to p f of xn, which can be written as 1 minus nabla raised to minus pyn. Here the value of e is equal to 1 minus delta raised 1 minus nabla raised to minus 1, and f of xn stand for yn. Then f of x become 1 plus p nabla plus p minus 1 p plus 1 upon 2 factorial nabla square plus p plus 1 p plus 2 upon 3 factorial nabla cube plus and so on into yn, where x is equal to xn plus ph. Then the final formula for Newton's backward interpolation formula is obtained as f of x is equal to yn plus p nabla yn plus p plus 1 upon 2 factorial nabla square of yn plus p plus 1 p plus 2 upon 3 factorial nabla cube yn plus and so on, where p is equal to x minus xn upon h. This is Newton backward interpolation formula and it is used to interpolate or extrapolate values near the end of the table, where p is the index which is 0, where x is equal to xn. Now let's discuss about the interpolation with unequal interval. For the function y is equal to f of x with given discrete set of points xi, yi, where I run from 1 to 0, 1 to 3, 0, 1, 2, 3 up to so on n, where xi are not equispaced. Common methods of interpolating data points are listed below. Newton's divided difference formula and Lagrange's interpolation formula. These two formulas are used to find the interpolating values of the data for unequal intervals. Out of these two methods or two formulas, in this session we are going to discuss on formula of Lagrange's interpolation formula. Lagrange's interpolation formula is given by when y is equal to f of x takes the value y0, y1, y2 up to yn for the arguments x, taking values x0, x1, x2 up to xn. Then the polynomial by Lagrange's interpolation formula is given by f of x is equal to summation from I to I is equal to 0 to n. Li yi is equal to L0 y0 plus L1 y1 plus L2 y2 plus up to so on plus Ln yn, where the values of L0, L1, Ln are given by L0 is given by x minus x1, x minus x2 up to so on x minus xn. In the value of L0, we skip the difference between x and x0 and take the differences of all the given data points of x and subtract these values from x in numerator, divided by, in numerator we skipped the difference between x and x0, so take the differences between x0 and all other values of x, that is x1, x2 up to xn, in the denominator. So we can write x0 minus x1, x0 minus x2 up to so on x0 minus xn. Similarly, the value of L1 is given by, here we have to skip the value of xn, x1 in the numerator and take the differences from x1 to all the values of x, that is L1 is given by x minus x0 into x minus x2 up to so on x minus xn, divided by x1 minus x0, x1 minus x2, x1 minus x3, like x1 minus up to x1 minus xn. Similarly, the value of ln is given by x minus x0 into x minus x1 into so on into x minus xn minus 1 divided by xn minus x0 xn minus x2 into so on into xn minus xn minus 1. By adding all these values of L0, L1 up to Ln and multiplied by y0, y1, yn to each term respectively, we get the final Lagrange's formula, which is given by f of x is 0 is equal to the value of L0 into y0 plus value of L1 into y1 plus value of L2 into y2 plus and so on the value of Ln into yn. So this is the Lagrange's interpolation formula for unequal interval. So in this session we discussed the formulas of interpolation for equal interval and unequal interval. There are mainly two formulas for equal interval, that is Newton forward and Newton backward formulas, and for unequal interval interval we discuss Lagrange's interpolation formula. Okay, with this point we will stop this session here, and in next session we are going to discuss on some formulas related with Newton's forward interpolation formula, Newton's backward interpolation formula and Lagrange's interpolation formula. Thank you.